Okay, so this is a Grignard reagent practice quiz for you. I've got 10 problems. This is meant for you to just pause the video and work out the problem yourself, and then check your work with mine, where I will give a very brief explanation for each one. If you're having trouble with these, I just encourage you to, look at the answers, look at the final product, and really try to visualize what's different from the original starting material. And just try to pick up on any patterns with that there. But so let's go ahead and look at this first one here. I've already drawn these out. Hopefully it'll save you guys some more time. Okay, so what's going on? We know there's minus charge here plus here with the Grignard reagent. That is our site of attack, so we're adding on there. We know that would kick up the bond there, giving the O a minus charge, and we would add on our carbons. Just 2 carbons right there. And then we know that this would ultimately protonate the oxygen there. That would be a product for the first one. Okay, number 2. Again, we know this is the site of attack for the nucleophile, which the minus charge is right here. We can do that plus there. We're going to attack the CH3. 1, 2, 3 carbons we added. There will be 1, 2, 3. These, and then our O. Oops, I hope that doesn't look like a double bond. We know our O would be protonated from the dilute acid right here. So we're just adding on whatever carbon chain is on the Grignard onto the site of nucleophilic attack. Okay, so this is a retrosynthesis problem right here. So there's actually several ways you could go about this problem, but let's just me first looking at this the way I drew it. I would say you could start with either an ester or an acyl halide. Wouldn't matter what group you have on there, because we know, and let me do, acyl halide just like this, and we could react, not together, but each separately. We would react it with the same starting material. It'd have to be 2 moles of 1, 2, 3 carbon Grignard, so 1, 2, 3 MgBr. I ran out of room. Should be all right. And that's each one. Let me draw that just so hopefully that's a little more clear. Yeah, now you could have started with a ketone for this one as well. You could have done, I think that's enough carbons there. You could have started with that, which that's actually the intermediate. Think you add your first Grignard. It's going to add right there. This is going to kick off. This would reform. The ester would leave. You would have a ketone intermediate after adding the first Grignard. And the second one is what gets you this final product here. So hopefully you can see how that's similar. Let's take a look at this next one. Okay, so where's our minus charge? Our minus charge would be right here on that carbon. That's our plus. Minus charge is attacking here. It's always attacking that carbonyl carbon. Let's try not to get too messy. We know it's going to get protonated in the long run. You can just draw a big phenyl group just like this. That benzene ring just hanging off. There's the rest. Okay, minus charge here. Attacking carbonyl carbon. Oh, well, actually, look at that. This is a carboxylic acid. Yes, you got to watch out for that. These won't react with carboxylic acid. This is actually going to grab this proton here. That's a lot easier to get to, if you think about it, than this site here. This is why Grignards cannot react with carboxylic acids, because it's just going to grab that, form your carboxylate ion, something like that, which is very unreactive. And that's not the product we're looking for, generally with Grignards at least. So Let's just write no reaction. You could put or no reaction. Grignard's not react with carboxylic acids again. Okay, so we have a retrosynthesis here again. Again, there's going to be several products. Let's go ahead and just when I look at it, I think the easiest thing to see would be start with an aldehyde like that, and then you could just add, steps 1 and 2. You could just add, let's just do it like CH3 MgBr, like that, and the minus charge is right there, and then your dilute acid. Let me swap to another color here just so you can see this a little easier. Or you could have done, you could have started with just a little aldehyde like this, and reacted that with steps 1 and 2. Like this giant Grignard. You can't see that. Looks something like, I'm trying to make sure I've got all the right carbons here. Oh, wait. Obviously, there's not going to be a carbonyl on your Grignard, but there we go. 1, 2, 1, 2. Yeah, that's right. And do that with dilute acid as well. Okay, so this one, number 7. Let's see. We are just trying to tell me what the reactants are for this, what the reagents are for it. Okay, so we see we're starting with an ester here, and we are ending with these 2 carbon chains. So it looks like we're definitely adding something twice, a Grignard twice. So we know we'll need 2 moles to react with esters anyways, else you're just going to get a ketone. Actually, I don't think that reaction even occurs, but and let's see, what are we adding? That's just 1, 2 carbons here, 1, 2 carbons there. So 1 carbon, 2 carbons, MgBr. There's our Grignard. Obviously, we're going to need it in dilute acid to give us that hydrogen up there. Okay. Number 8. Okay, nice. So this is an epoxide. So hopefully we know that the site of attack for these is going to be right here on this very exposed carbon right there. So same thing. The Grignard is going to attack right here. And that is going to all unfold out. And it's going to get protonated like that. If you want to count your carbons, you go 1, 2, 3, 4 carbons there. Oh, I think I missed a carbon. I'm sorry. There's 1, 2, 3, 4 carbons. We're tacking up 4, and we're adding these 2. So our new carbons, 1, 2. Hopefully you can see that. Okay. Let's go back to blue. Okay, so this one, what was our original product here? What was our starting material? Okay, so this is kind of like a retrosynthesis. We're working backwards. You can see this is a carboxylic acid. So how did we form a carboxylic acid from a Grignard? Probably just memorize that one. Whoops. Maybe you haven't memorized. It would be carbon dioxide would form that. You can check your work. The minus is here again. I think that's going to go attack right there. One of these bonds is going to go up, giving you the minus charge. You can do 1, 2, and then dilute acid will come and protonate that in step 3. And if you picture that, we now have 2 carbons on there, right? That would be right there and there. That's our original carbon right here. And the OH is from one of those that got protonated. Okay, the last one. Okay, so now this isn't, we should recognize this is not a Grignard reagent here, but I thought this was important to throw in because this is the formation of a Grignard. So hopefully we know that, with these reagents, any alkyl halide like this, an Mg and Et2O, we're just going to squish that magnesium in there to form our Grignard, MgBr, just like that. I'll just write, in case you want it, Grignard, I think that's spelled close to right, formation. Okay, so there's 10 problems. I hope this helps to just practice and get these, so you can just look at it and just get the right answer. I think it helps a lot to just visualize the product exactly, where we're adding our carbons. You can see, here, there's just 2 chains of carbons. I know this is really sloppy now. I've written all over this, but yeah, and we just had 2 carbons here, and now the final product is 2 carbons. We know we're adding on the carbonyl carbon. Okay,